Welcome to the e-learning course for Asprova hands-on training. 2F Order Inventory Pegging and Auto-Replenishment Production. There are various types of orders. 1. Sales order. Enter here information about a customer order received. By pegging a sales order to a manufacturing order and a purchase order for the same item, you can tell when the sales order can be fulfilled. You can peg a sales order to multiple manufacturing orders and purchase orders. 2. Manufacturing order. Enter here an item to be produced inside the factory. Asprova performs order explosion using the master data registered in advance and generates operations for the order. Those operations will then be assigned to locations on the time series of each resource and peg the sales orders and manufacturing orders. Manufacturing orders can also be generated automatically to supplement sufficiency using the auto-replenishment production feature. 3. Purchase order. Enter here a finished item, an intermediate item, a raw material to be purchased. A purchase order is pegged to a sales order and a manufacturing order. Purchase orders can also be generated automatically using the auto-replenishment feature to supplement insufficiency. 4. Inventory fluctuation value. Enter here information about decrease and increase in the inventory level that occur other than 1, 2 and 3. Inventory can be pegged to a sales order and a manufacturing order. 5. Inventory absolute value. Register here actual inventory counts. Patterns of order processing. 1. Pure make to order. For each received order, you create master data for the item of the order. Since the master data, sales order and manufacturing order are in a one-to-one relationship, you can omit the sales order and maintain the data only by the manufacturing order. 2. Repetitive make to order. You create a production schedule according to received orders. The same master data is used repeatedly. 3. Assemble to order. Before receiving orders, you create a production schedule for the immediate items by forecast, and as soon as an order is received, manufacturing orders prepared in advance are pegged to the received order. Let's look at the master data to be used in this section. The component parts A and X are assembled to produce the intermediate item AX. AX is then packed into units of 100 to become AX100. Each process has its own master data. Starting Asprova. Click on the Start button to display the Windows Start menu. Select Programs, Asprova APS, Asprova from the menu to start Asprova. Pattern of order processing. 1. Pure make to order. In the case of pure make to order, the master for ordered items are prepared for each item. As a one-to-one relationship exists for the master, sales order and manufacturing order, intermediate goods are pegged by one-to-one from the point of time when the order is received. Since this is a one-to-one relationship, you can omit the sales order and control it with the manufacturing order only. In the case of pure make to order, the master is required for each sale. In this situation, there arises the issue that the master setting cannot be made in time. You can cope with this issue utilizing the following features. 1. You can temporarily utilize the existing master while making use of the items for order explosion. 2. You can decrease the number of the master registrations by utilizing the parametric master you experienced in exercise 2a. Open the project file. Select File, Open from the main menu and select as2f.ar4 from the folder Basic 2f1 Pure Make to Order to open the Asprova project file for this training section. Let's set the auto-replenish flag for AX100, BX100, CX100 and the child parts. Change to the item table. Set the auto-replenish flag to Yes, 1-to-1 production. Suppose that we have received orders for AX100, BX100, CX100 and DX100. For pure make-to-order, you usually create master data after obtaining order information. However, for simplicity, we assume here that the master data has already been created. First of all, let's take a look at the order table. Currently, there are no orders registered in the order table. Let's import the order information. By selecting Import, the manufacturing orders will be created as shown. We have 4 manufacturing orders. The Item for Order Explosion field is used to specify a master object to be used for order explosion. If no value is specified, the master data of the item specified in the item field will be used. For this example, it means that DX100 will use the master data of CX100. Let's reschedule and see how the manufacturing orders for each item will be auto-generated. Each auto-generated order has been pegged 1-to-1 and assigned forward. Let's check the schedule results on the order Gantt chart. You can see that order M04DX100 has been exploded using the master data of CX100. If you specify Yes, 1-to-1 for automated replenish flag, you can automatically generate 1-to-1 order for the child part based on the sales information in order to execute pegging and assignment. Automatically generated 1-to-1 order is not grouped for the order generated from the other parent order. You can utilize 1-to-1 production if you prefer neither pure make-to-order nor grouping production. You can make a schedule by having manufactured orders auto-generated based on order information. You can tell from scheduling results when ordered items can be obtained. As we use the master data of CX100 for scheduling DX100 by preparing a single template master data record, you will not need to register the same master data repeatedly. This is the end of pure make-to-order. Pattern of order processing 2. Repetitive make-to-order. In this exercise, for all of the items to be produced inside the factory, we will make a schedule using the auto-replenishment production feature. If you use this feature, manufacturing orders will be automatically generated so as to maintain the safety stock for each item. Open the project file. Select File, Open from the main menu and select as2f.ar4 from the folder Basic 2f2 Repetitive Make to Order to open the Asprova project file for this training section. Open the item table. Set the auto replenish flag for A, AX, X and AX100 to Yes. Set the production lot size max for A, AX and X to 400. Set the production lot size max for AX100 to 1. Set the production lot size unit for A, AX and X to 400. Set the production lot size unit for AX100 to 1. Next, let's import the orders. Open the order table. Let's import the order table. From the File menu, select Import. We have imported 5 sales orders for the item AX100. This time we will assign the orders backward. Since priority is set to 80 by default, orders will be assigned backward if we do not specify any other values. As you can see, the 5 orders have been automatically generated for each item. Change to the order Gantt chart. Reschedule. Let's display the whole area so we can see all of the orders. You can see that the manufacturing order for each item has been automatically generated and assigned according to the demanded quantity and the lot size. Let's return to the item table to check the inventory for AX. Click the right mouse button over the item AX to bring up the pop-up menu. Select Composite Chart, Item Assigned Resources. A custom chart is displayed. The quantity of AX100 required by the 5 sale orders is 500. However, according to the setting of the production lot size, 2 replenishment orders with the quantity of 400 have been automatically generated. As a result, a surplus of 300 occurs. To eliminate the surplus, we will change the size of the auto-replenished orders. By setting the production lot size unit for the items A, X and AX to 100, the surplus should disappear. Return to the item table. Set the production lot size unit to 100. Return to the order Gantt chart. Reschedule. You can see that the size of the auto-generated orders has been recalculated and the orders have been reassigned. Change to the custom chart. If you check the inventory graph for AX, you can see that no surplus occurs this time. By adjusting the production lot size unit, flexibility is given for the sizing of auto-replenished orders, which enables us to create a schedule with no surplus. Furthermore, let's change the production lot size max to a smaller size and try to reduce the overall lead time and inventory. Return to the item table. Set the production lot size max to 200. Return to the order Gantt chart. Reschedule. You can see that the overall lead time has been reduced. Change to the custom chart. The period of holding excess inventory has been shortened as well. You can automatically generate and assign the manufacturing order for a child part in accordance with the manufacturing lot size by specifying yes for auto-replenishment flag. If you pay attention to a child part, you will see that a lot size in production is performed in accordance with the manufacturing lot size. You can peg sales orders while considering existing orders and inventory. You can use the auto-replenishment production feature to generate manufacturing orders automatically. You can give flexibility to the size of auto-replenished orders to make a schedule with no surplus inventory. You can reduce the lot size to make a schedule to reduce lead time and inventory. This is the end of repetitive make-to-order. Patterns of order processing 3. Assemble to order. Here we will plan manufacturing orders for component parts A and X to carry out the production before receiving orders, and later register order information as manufacturing orders. Open the project file. Select File, Open from the main menu and select as2f.ar4 from the folder Basic 2f3 Assemble to Order to open the Asprova project file for this training section. Open the order table. Currently there are no orders registered. Let's import the order information. Manufacturing orders for the component parts A and X and inventory orders for A and X have been imported. Open the order Gantt chart. A forecast manufacturing schedule has been created. And reschedule. Next, let's suppose that we have received an order for AX100. We will register manufacturing orders for the item AX100. Also, we will assume that the due date for the sales order is so early that the manufacturing orders planned in advance cannot meet the due date. Change to the order table. Register a new sales order. 01 AX100. After entering the new order, return to the order Gantt chart and reschedule. You can see that A and X are covered by inventory and the orders are scheduled to be completed in time for the due date. Currently, the inventory valid period is set for order I02X. When the inventory valid period is set, a green triangle will be displayed on the order Gantt chart. The inventory valid period specifies a valid period for the item after production. Suppose that the inventory valid period is changed to 1 day earlier than the current schedule. Return to the order table and change the inventory valid period. Change the inventory valid period from October 2nd to October 1st. Return to the order Gantt chart. Note that the inventory valid period is now 1 day earlier than before. Reschedule. In this schedule, the orders are not pegged to inventory I0 to X, of which the valid period has expired, but it is pegged instead to M01X, for which the item is supposed to be produced by forecast. Next, let's assume that we have received an order with quantity that cannot be covered by existing inventory and manufacturing orders. Return to the order table. Specify a new sales order, S02AX100. The quantity of the new sales order is 2, and it is obvious that existing inventory and manufacturing orders cannot cover the quantity of the new sales order. Nevertheless, let's return to the order Gantt chart and reschedule anyway with this new setting. Reschedule. Change to the resource Gantt chart. From the result of scheduling the sales order S02AX100, it seems to be completed by the due date. However, a message, insufficient input quantity, input instructions 2, is showing in the message window. Double-clicking on this message row will bring up a dialog window telling you which instructions have insufficient quantity. Click the Jump button to bring up a table showing the related objects. You can see that although order 02AX100AX requires a quantity of 200 of item A and item X, the remaining quantity that has not yet been pegged is 100 of A and 200 of X. Let's check the result on the inventory graph as well. Let's add new manufacturing orders for items A and X. You can see from the inventory graph that there is a shortage in items A and X. To supplement the shortage, let's add new manufacturing orders. Return to the order table. First of all, let's add a new manufacturing order for item A. Next, let's add the new manufacturing order for item X. After adding the 2 new manufacturing orders, let's return to the order Gantt chart. Reschedule. If you reschedule, you can see the shortage of items A and X will be supplemented by the manufacturing orders we added. Let's check the status of the inventory on the inventory graph. As you can see, by adding the manufacturing orders, the shortage in inventory has now disappeared. You can peg existing inventory of intermediate items, such as component parts and planned manufacturing orders, to a sales order and manufacturing orders of the sales order. You can register component parts as inventory and manufacturing orders and use the auto-replenishment production feature simultaneously. Asprova calculates the shortage of items and encourages the user to add orders. This is the end of Assemble to Order. This is the end of Asprova Hands-on Training 2F. Thank you for watching.